Chapter 5, Lessons 5 and 6 are on the Pythagorean theorem. Some vocabulary. We are dealing with right triangles. That is a triangle that has one right angle. Here's an example of one. And the right angle would be here. And we use the box to denote that that is the right angle. We have the legs. Now, in a right triangle, the legs are the sides that form the right angle. So if I have this right angle, remember the box, the two sides that make the right angle are being marked in blue, and those are the legs. Where the hypotenuse is the side that is opposite of the right angle. And we use these to help us describe the pieces of a right triangle. Because if we put these pieces in the right spot in an equation we're going to learn, it will help us find any missing piece that we might not have. Then we have the Pythagorean theorem, and it states that in a right triangle, the sum of the squares of the lengths of the legs equal or are equal to the square of the length of the hypotenuse. Now that's a lot of different words being introduced. Let's go back to the legs and the hypotenuse. We have two legs, and we're going to call one of those A for its variable, and the other one B for its variable. And then C, which all of these are coming from the equation, C is going to be the hypotenuse. C is always the hypotenuse. Letter C is always the hypotenuse. As we learn the equation, there is an interesting relationship made by the two legs and the hypotenuse. With the Pythagorean theorem, we have what's called the converse of the Pythagorean theorem. And converse, in this sense, is if I take a definition and I turn it around backwards, if that is still true, so in this case, I'm taking the Pythagorean theorem, turning it around backwards, and when I do that, it is still a true statement. And that converse says, if the sides of a triangle have lengths A, B, and C, such that A squared plus B squared equals C squared, then the triangle is a right triangle. So what it means is if I were to say, hey, these are 3 measurements, is it a right triangle? And we can use the Pythagorean theorem to help us actually prove that. Going back to the green definition, the Pythagorean theorem is going to help us find missing measurements. So the Pythagorean theorem will help us find missing lengths, and its converse, or just looking at it backwards, if I have 3 measurements and I can put them in that equation and it is a true statement, then I have a right triangle. This equation of a squared plus b squared equals c squared will be the basis of what we do in each question, where we're going to take measurements, place them into the equation to help us find a missing measurement. Here is a large diagram again when it comes to which sides are the legs and which side is the hypotenuse. I also marked A, B, C. I will tell you that when it comes to A and B can actually be flip-flopped. The only one that 100% matters is where C is located. C is always opposite the right angle, meaning it is across from the right angle. See how I circled it and then drew an arrow? That arrow is pointing to C. Something to note is that C is always the largest length in a right triangle. The way this theorem works, C will always be the largest side of a right triangle. And that's going to come in handy because sometimes we're going to have to figure out which side is A, which side is B, which side is C. And this fact of C being the largest measurement is going to be needed for that piece. Let's actually put this to use. So the first type of question I want to talk about states, write an equation you could use to find the length of the missing side of each right triangle. Then find the missing length, round to the nearest tenth if necessary. I see 2 right triangles, so that means I must use the Pythagorean theorem to find the missing side length. What we need to know is some teachers will always tell you that when it comes to your two legs, see, here's a leg and here's a leg. That means one of those is A, one of those is B. And some teachers will instruct you to make the smallest one A and the other one B. That is a strategy. I am going to also tell you that it actually does not matter which one is A, which one is B. The only measurement that has to be in the correct spot is C, the hypotenuse. Let's go ahead and put the pieces into the equation. Here, let me use some color coding. So for A squared, A is 9. It becomes 9 squared plus B squared is 12 squared equals C. Well, we don't know what C is, so C is going to remain a variable. This is going to give us an equation, and we can use equation solving skills to help us evaluate and get the C by itself. And here's where we'll begin. First, we need to evaluate the squares. Meaning I'm going to do 9 times 9 and 12 times 12, because that is what squared means, a number times itself. 9 squared is 81, plus 12 squared is 144, is equal to C squared. Now we're continuing to try to get C by itself. What I notice is I do need to combine some like terms. So the 81 plus the 144, I get 225 is equal to C squared. And this next part we have not seen since the beginning of the year, and that is, how do I get C by itself? C has a square on it, so I need to find the square root. So what I'm going to do is find the square root What's nice is now C is all by itself, and I must find the square root of 225. something to remember about square roots. Square roots have two answers. The positive 15 and the negative 15 are both the square root of 225. Now, when we're dealing with measurements, so measurements are positive. So when I go to get my answer for this, I do not need the negative. What I need is the positive answer. So here, C is equal to 15. There are two varieties when it comes to the Pythagorean theorem. In this one, notice we had to combine like terms by adding them together. That is when we are trying to find the hypotenuse C. If I am looking to find the legs, you're going to notice a slight variance in the steps that I follow. Let us take a look by following through with the second example. First, we need to go ahead and find which sides do we have. I have B as a variable, so I'm finding a leg. Let's see, here's my right angle, and that means the side that is opposite of it is C, which means the 8 must be my A. Again, C is the one that's important. The hypotenuse is always the side away from that right angle. Now we're going to go ahead and fill in that same equation. A squared plus B squared equals C squared. A is equal to 8, so 8 squared plus B, we don't know B, so the variable goes there. B squared equals C squared, but C is 24. So instead, it's 24 squared. Let's now go through and solve. First up, we're going to do the squares again. So that's 8 times 8 and 24 times 24. 8 times 8 is 64 plus B squared, because I have not and I cannot evaluate the B. $24 squared is 576. I am looking to get B by itself. That's what I'm solving for. So on that left side where B is located, I want you to notice I have a 64, a constant number, and I have to move the constant numbers all to one side away from my variable. So I, in this case, am going to subtract. And I am subtracting to take the 64 and remove it from the B squared. Now, 576 minus 64 is 512. And I have B squared is equal to 512, which takes me to one more step, and that is to now evaluate and find B. To do that, we are going to take the square root Now let's see. Using my calculator, the square root of 512, I get a really long number. And they asked us to round to the nearest 10th place, back up in the instructions. So for my answer, I'm going to do that. It says 22.62, so that means 22.6 is how I round it off. Remember, square root is two answers. For our purposes, to find a measurement, I need the positive answer. Moving forward, there are going to be examples of more application questions of looking at the Pythagorean theorem. And I'm going to move through them a little faster. Always pause if you need to, or slow down the video to be at a better pace for you. Write and solve an equation that can be used to find the length of the ladder, then solve. Round to the nearest 10th. What we have is a ladder being leaned against the side of a building. Now, buildings are, for the most part, perpendicular to the ground, which forms a right angle. The ladder is on a slant, and it happens to create for us a hypotenuse. So this creates for us a right triangle. And if I want to find a missing length in a right triangle, we have the Pythagorean theorem of a squared plus b squared equals c squared. I see that. Again, the hypotenuse is always c. We'll say A is the 8.75, while B is the 18. Remember, A and B, the legs, it does not actually matter which is which, as long as C is the hypotenuse. Now, I'm filling in each variable where it belongs. And by solving this equation, we can find the length of the ladder. First, the squares. I got to check 8.75. And I get 76. I'm going to round this, 0.6. And then 18 squared is 324. And that is equal to C squared. When I'm finding C, the hypotenuse, that is when I'm going to be adding like terms. So we're going to go ahead and add the 76.6 and the 324 to get 400.6 is equal to C squared. In order to finish solving for C, I must evaluate for the square roots. When I put this in, I get 20.01. But if I'm rounding to the nearest tenth, that means my answer is roughly 20. We know square roots are positive and negative, but since we're talking about a measurement, I need the positive. So we find that the ladder is about 20 feet. Using the exact same steps. The part you have to figure out is which part is which variable. Here's another type of application. Write an equation that can be used to find the height of the plane. Then solve. We have two planes flying in different directions. What we know is that there's a horizontal distance of 10 miles, and the exact distance between them is 12 miles. And we can use that to find how much higher is one plane to the other. Here is my right angle, which means that the 12 is C. B is what we're looking for. So 10 is A. And it is a right triangle. So again, we're going to use the Pythagorean theorem. A squared becomes 10 squared. B Well, we don't know what b is, so it stays b squared. C squared becomes 12 squared. To solve, we start with the squares. 10 squared is 100. We don't know b. And 12 squared is 144. Now, since I'm solving for a leg means I must subtract. So I can get the b portion by itself. And I'm left with b squared equals 44. To finish finding what b is equal to, we're going to take the square root. B then is equal to, let's see, I got 6.6. And even though square roots come out with a positive and negative answer, we're talking about measurements, so I need the positive. So the Pythagorean theorem, there are two types of problems: finding the hypotenuse and finding a leg. And whichever one you're doing will determine when you have to add, when you have to subtract. Now, the Pythagorean theorem can be used in more three-dimensional spaces. What we saw were more two-dimensional pictures. We'll get to that in a second as we start talking about more applications that you could visualize. In this case, it says Mr. Parsons wants to build a new banister for the staircase shown. Let me actually talk about what that is. If you have stairs, we're talking then about like the fancy railing when it comes to the stairs. It says if the rise of the stairs, meaning the vertical distance, the rise is 5 feet and the run is 12 feet, what will the length of the new banister be? So if the rise and the run represent the legs, I have a right triangle. It means that the banister is our hypotenuse, C. As for A and B, I'm going to make the 5 feet A, 12 feet B. Some teachers, again, would suggest making the smallest one A, which is what I did here. And we can go ahead. This diagram makes a right triangle. So let us solve the Pythagorean theorem. And I want you to think ahead. Am I going to need to subtract in this one or add? And it's okay if you don't know. The point of that is that some people think about their problems in that way. They recognize that there are patterns to what's happening and that certain scenarios require certain type of work. All right, I'm going to start by solving the squares. 5 squared is 25. 12 squared is 144, equal to c squared, because I do not know c. When we're finding the hypotenuse, we tend to find we must combine like terms by adding them. So we're going to take 25 plus 144 to find 169 is equal to c squared. In order to finish, we need to find the square root of 169 is 13 and negative 13. But as a reminder, we're talking about measurements. So we need the positive answer. A lot of examples in this video. I appreciate sticking with it, but we need to see different situations in which the Pythagorean theorem might be used. A three-dimensional example could be a flagpole. A 12-foot flagpole is placed in the center of a square area. We see that in the picture. To stabilize the pole, make sure it stays in place, a wire will stretch from the top of the pole to each corner of a square. The flagpole is 7 feet from each corner of the square. What is the length of each wire? So in the description, there would be a wire going to each corner. And it kind of creates this rectangular, actually it's more of a pyramid. It makes a pyramid shape. And when we have a pyramid with a square or triangular bottom, we can actually create a right triangle if we know how far apart the pole or the center of the pyramid is from one of the corners or even one of the sides. In this diagram, we're using the pole, its distance from the corner, and it creates a right triangle with the wire. To solve this, first off, we need to see that the wire is the hypotenuse. So my measurements of 7 and 12 are the legs. And since we could create a right triangle, we go with the Pythagorean theorem. I'm going to go through the steps. We'll go ahead and square these. Now consider we are solving for the hypotenuse again. Will I be adding or will I be subtracting? I will be adding. Before I find the square root. Let's see, I get 13.89, so that rounds to 13.9. And I need the positive answer. To wrap up this video, I'm going to demonstrate how the converse of the Pythagorean theorem works. I have three measurements, and it says determine whether each triangle with sides given lengths is a right triangle. Despite the grammatical errors, let's see what we have. 36, 48, and 60. I have to assign each of those a variable, A, B, and C. We need to remember that C, which is that hypotenuse, is the largest measurement. So the 60 has to be my C, which means the 36 and the 48 are my A and B. If I place those into the Pythagorean theorem, I'm trying to find out, is this actually equal? So let's see what we have. We will go ahead and square everything. And we'll go ahead and combine like terms on the left. And again, I'm trying to find if the left and the right side are going to be equal to each other. In this case, they are equal. Therefore, this is a right triangle. For the next example, I see 7 is the largest, so it's C. So the remaining two are A and B. We'll place them into the Pythagorean theorem and decide whether or not this is a right triangle. Now, these sides can still make up a triangle. It's just that for the triangle to be a right triangle, it has to fit within this equation. That's kind of why I'm putting that question mark there. So we don't know if it's equal. Now, what I see here is 16 plus 25 is 41. So these are not equal. Therefore, not a right triangle. If you made it to the end, I highly appreciate it. You can always go back to any part. Please do not let the length of the video discourage you. And again, go back to any point to pause or to re-listen to get any information you might have missed.